Mm. All right. Before we start, is there any question regarding specific topics or specific problems? Do you have any?
Sir, maybe name game.
Okay, about name game. All right. About name game. So I think in the last meeting we have discussed that. Uh, right. Okay. Okay. I think I discussed it with the seniors. All right. So basically, name game is a game like this. There are some piles of stones, and for example, in the first pile, there are A1 stones. In the second pile, A2 stones, A3 stones, A4 stones, A5 stones. All right. Each player can take some stones from one pile. So, for example, in the first turn, uh, a player can choose a pile. For example, choose this pile and taking some stones. Of course, at least one, at most A2, right? A2 means taking all stones. All right. And then a player that cannot move, he will lose the game. Cannot move means, do you know when a player cannot move?
When all when all the piles will be empty.
Yes, when all of them are empty, then the game finish. Okay, it means if someone take all stones, then he will win the game because the enemy cannot move in the next turn. Alright. So if both player plays optimally, can we predict who will win the game?
I think it's some casework of odd and even we have to track.
Okay. Maybe let's check for n equal to one. For n equal to one, when the first player win and when the second player win. What do you think?
The first player always wins, sir, in this case.
Yes, the first player always.
First player always chooses the all the piles and he will win.
Yes, except if a1 is equal to 0. Okay. But if there is a constraint that a1 is at least 1, alright, yes, the first player always win. But if it can be 0, then if a1 is 0, then the second player win, right? Okay. So it means if a1 is equal to 0, then the second player, otherwise, if not equal, okay, not equal 0, then first player win. Alright. How about n equal to 2?
Sir, if both values are equal, then the second player will win, otherwise the first player.
Yes, that's it. Do you know why?
Yes, sir. What he will do is that if there is two distinct integers a and b, uh, the first player will try to make both of them equal, and then the
Yes,
second player will come. He has to make it unequal a and b, and it will so on until we both become zero.
yes, that's right. So when it is equal, then we must make it not equal. If if it is not equal, then we always can make it equal, right? So just make it equal, and then the enemy will make it not equal, and we can make it equal, and so on until we make all of them equal to 0, right? Okay, that's why uh, the game will be like this. And how about the general solution for any n?
Sir, it's like this that if the ZOR of all the elements is non-zero, then the first pair will win, otherwise the second pair. Because if the ZOR of all the elements is non-zero, then he will make it zero. ZOR. The second pair will come and it has to make it non-zero, and it will so on
Yes,
until all of
exactly.
them become zero.
Okay, like this, right? So actually it is general for this as well. If a1 equal to a2, it means the SOR value is 0, right? Okay. And also for this, if a equal to 0, then it means the SOR value is 0. Alright. Because if the SOR is 0, we must make it non-zero. We cannot make it still 0. And if it is not 0, and then we always can. There always exists a way to make it 0. Okay. Yes, that is the strategy for name game. Is there any question? Do you know the proof? How to prove this? Such that if it
Yes,
is
sir.
0, we must make it non-zero. If it is non-zero, we can make it 0.
Yes, sir.
Okay, yes. How?
So our Zor value will always be less than at least one of the like the I think no, it's wrong. I think.
Actually, we need to prove two things. We have to prove that if 0, we must make it non-zero. After that, we want to prove if it is non-zero, we always can make it 0. Alright? Okay, let's do it one by one. How about this one? Okay, any idea how to prove that if initially the SOR is 0 and we want to make one move and it will be non-zero?
I think we will subtract one from any of the pile.
Yes,
It will always make it non-zero.
yes, because it is changing, right? It is changing, for example, from A become B and A is not equal to B. It means, okay, let's say the SOR for all this is S. So the SOR for the initial array is S SOR A, and it is 0. And then SOR AB is always non-zero. Why? Because we know that A and B are different. So A SOR B non-zero. So S SOR B is equal to, is S SOR A is 0. It means S is equal to A. This is, and we know that A and B are different, so it is not 0. Alright, proven, right? And then we want to prove that if the SOR is non-zero, there always exists at least one way to make it 0, to make the SOR is 0. How to do that?
Take XOR of all elements, and it is sure that it will lesser than equals to one of the elements that is present in the array A.
I think
Okay.
it won't work
Yes.
because if we have the greatest bit on one file and the least bit on another file, then their ZOR will be greater than the maximum amount of the elements.
Yes. So, for example, initially the SOR is S. We want to make we want to make okay, let's say the SOR is initially as SOR A and it is non-zero. We want to make SOR B is 0, right? How to make SOR B is 0? Uh, wait. Okay. For example, SOR A is C and it is non-zero. So it means S is equal to A SOR C, right? And then it means this is X SOR P SOR C is equal to 0. It means A SOR P SOR P equal to 0. Alright. Sorry. X SOR P SOR P equal to C. Alright. So initially we can easily find C, right? By find the SOR for all elements. For example, we already know C. And then let's analyze most significant bit of C. For example, the bit of C is like this. Most significant bit of C is here. So of course there is at least there is odd number of value that this bit is on, right? Odd number, it means either 1, 3, 5. It means at least exists exists at least one, right? Okay. So just choose one element such that the MSB of C is on. If MSB of C is on, then okay, then change into B. B is A SOR C. Because in A the MSB is on. So if we sort them, then this MSB becomes 0. So it means B is less than A, right? We have to make sure that B is less than A, right? Because if greater than, we cannot add a stone, right? We can only remove a stone. But if the MSB is on, then this MSB will be turned off. So we can make sure that B is less than. What if this is not MSB of A? A is more than this. Okay, don't worry. For this, it will be same. But here, in A, it is true, but in B, it is false. So it means B is less than A, right? Okay. Okay, now it is proven. All right. Yes, that is the solution. And
Sir, can you
okay,
explain again? My meeting was not like I didn't see the first arrays. How did you do that?
Uh, okay. Okay. Should I explain this again? The proof of this, right? All right. We just want to prove that if initially the source is non-zero, then we always can make it zero. The solution is exists. Okay. So okay. Let C is source of all elements, right? It means C is source between S and A. All right. And then we want to change one element from A to B, but B should be less than A, such that the source is zero. So we want to make S source B is zero. You know, S is A source C, right? So it means A source B source C should be zero. It means A source B should be C. It means B should be equal to A source C. Okay. And we know that B should be okay less than A. Actually, for any A, B always exists in one solution like this. But sometimes B is greater than A, sometimes B is less than A, right? So we want to find an A such that A source C is less than A, right? We want to prove that it is exist. It is always exist. If it is exist, so just change that value. Just change that A into A source C. And A source C is less than A, so it means it is valid. Alright. How to prove that this A is exist A such that this inequality is satisfied? So the proof is like this. If we have C and let's check the most significant bit of C. Okay. C is source of all values, right? So if at some point C is true, it means there are odd values such that this bit is true, right? If this is false, it means there are even number of value that the bit is true, right? Okay. So if we check in most significant bit, of course the most significant bit is 1, right? Because C is non-zero, so there is most significant bit and it is always 1. So it means the number of value in the array such that this bit is on is odd. Odd means exists, right? Odd means exists. But
Got
even,
it. Got it.
yes,
I got it.
yes, at least 1 or 3 or 5. So at least 1, right? But for even, sometimes it is not exist. Sometimes 0, sometimes 2 or more. Alright. So it means it is exists A such that this bit is on. You know, hmm, if the bit of A is turned on, sorry, the bit in most significant bit is turned on, then this inequality will satisfied. Why? Because, okay, for example, this is C, this is 0, 0, 0, this is any. For A, it is any, this is 1, this is any. Or let's say This is X, this is Y, this is Z. If we sort them, the value will be Y 0 XOR Z. You know, in this bit, all of them are equal. But here, A is greater than B, right? So it means this inequality holds, right? Okay, it is proven. We can prove that it is exist. Okay, yes, I think it is. It is easy to solve it. Okay, by the way, tomorrow, I think. Wait. Okay, yes, I think tomorrow morning at 11 p.m. 11 a.m. maybe. Or wait, 12 maybe. At 12 p.m. there will be a contest. You can participate it when you are ready. Uh, okay, you can start anytime uh, within the duration.
So we will do this one instead of that we have to do every
Yes,
Wednesday.
yes, and I hope you can participate in both contests.
Yes. No.
Okay, and also in
That will be 10 hours and it will be too much for us.
okay, yes, this is in Monday, I think, for this Monday.
This one. Yes, we can participate in this one.
All right, yes,
I
good
thought
luck
you were
then.
talking about that we have to do the Wednesday contest as well and the one you just showed us.
Yes, I recommend this contest. All right, and then wait, wait, is there any English question? Okay, there is a good problem about again about source. That's why I recall this problem. Okay, okay. Can we discuss this problem? Okay, okay, please read the problem and try to understand this.
sir. I have read the problem and I think I have got the solution as well.
Okay. How?
Actually, I think the condition that is given over here, that GCD of A of I comma A of j is lesser than XOR of A of I comma A of j, is that if GCD of A of I comma A of j is not equals to, you can say, max of A of I comma A of j, then we have to multiply at least A of I, both A of I and A of j multiply by 2, and the bits will shift left of each of the element, and that will always be greater than the XOR of A of I comma A of j. So the problem reduces with like that we have to find number of pairs such that GCD of fi comma f j is equals to maximum of fi comma f j, and then we have to just counter counting.
Okay. Yes. So, okay. Let's say we assume A is less than B, for example. So the maximum is B, the minimum is A. Okay. Do you know what is the relation between GCD and SOR? Okay, what is the relation?
I think he misunderstood GCD by LCM.
Wait. Okay, maybe. GCD is smaller than A or greater than A?
Always less than or equals to the minimum.
Yes, less than or equal to minimum. Alright. Okay. Okay, so do you have any other idea?
I have an observation, which
Oh,
is that
yes.
if we are like taking two numbers, if like those who don't have same most significant bit, for them, GCD will always be lesser than XOR of them.
Yes. Okay. If the most significant bit is different, how to prove it?
Because the most significant bit of A will be present in the XOR, but the GCD will always be less than or equals to minimum. So most significant will not be present in the GCD. So it is proven that
Yes,
the one
that's
which
it.
has most XOR has most significant bit, so it will always be greater.
Yes, exactly. Okay. All right. And then what if most significant bit of A equal to most significant bit of B? Let me give you some hints. There are two cases when A equal to P or A less than P. Okay.
Sir, I think I have got the solution.
Okay, yes. How?
Sir, what we will do is that we will do the complementary counting instead of saying that we have to count GCD of A of I, comma Fj is lesser than Zor
Yes.
of both. We will count the greater than equals to GCD of A of I, comma Fj is greater than equals to Zor,
Okay,
and
yes.
then we will minus it from the whole number of pairs. And how to count that? Uh, we will count that we will split it into two cases. That first only the greater one and the one with only equals. So
Okay.
how to count those that have GCD of uh, a of I comma a of j is greater than equals to their Zor? We can say that mm, it will 1 second minus y.
What if A equal to P?
uh, a equals to for a equals to b, it's simpler that it will only exist that GCD of x comma y will be equals to x minus y, assuming that x is greater than equals to y.
Okay, yes.
And for the other case,
You think, sir, don't you think it should be true instead of false? Because GCD of A comma B will always be equals to A and B, and Zor will be equals to 0.
Okay, it means true for this, right?
Yes.
Okay, okay, because we count the complements. Alright, then this is true. Okay, true in complement. Alright. How about A less than P? Do you know that GCD AP is equal to GCD A comma P minus A?
yes, sir.
Is it correct? Because A and P
Yes,
are different. So it means it is less than or equal to P minus A, right?
yes, sir.
And do you know
Uh,
that?
I got the solution.
Okay, yes. How?
And then the Zor will always be greater than equals to b minus a.
That's it. Alright. So it means either they are same or they are less than, right? Okay, if less than, it means false in complement, I mean. So, okay, this is true, right? So how to solve this? We just need to calculate this, right? Okay. Do you know why SOR always greater than or equal to P minus A? Okay, because like this, for example, this is P, A, this is the SOR, this is the minus. There are four cases. If at some bit both of them are 0, what is the SOR?
0.
0, right? And the minus?
0.
0.
0.
Alright. So it means this is equal, right? They are equal.
Yes.
How about if 0, 1? What is the SOR?
1.
1, okay. What is the minus?
Uh, it will be
Minus
minus 1.
Minus 1, right? So it is greater. How about 1, 0?
1.
1.
1 and 1.
1.
So they are equal. How about the SOR of this?
1.
0.
0 and this? 0.
It's
0.
So it means it is greater than or equal, right?
Yes.
Okay. Yes. So, okay. This is proven. And this is also proven. So it means GCT never greater than SOR. So it means we just need to calculate this, right? And then how to calculate this?
Sir, it would be like GCD of x comma y will be that we have to count the pairs at that GCD of x comma 2x maybe. Yes.
X comma 2x. Yes.
That exists.
If x with 2x, it will be equal if and only if GCT is equal to b minus a and SOR is also equal to b minus a, right?
Yes.
Okay. So how to calculate them? Okay. Mm.
Sir, for the second condition, the pair that we only count, they both will be equal. That x will be equals to a will be equals to b.
Okay. A equal to b. Wait. We need to count these two cases, right?
Yes, sir.
For this case, it is easy, right? Just
Yes.
find the frequency of each number and just find the combination. And how about this?
I think it's the case
Yes.
of uh, the what we write B and A.
Okay. Okay. The idea is like this. The GCT of AP, of course, it is a factor of A, right? So if the GCT is equal to the SOR, so it means A SOR B also a factor of A, right? So let's brute force for every A and then for every factor of A. For example, X is factor of. So we just need to check like this. If X is equal to A XOR B, it means B is equal to A XOR X, right? And then we have to make sure that, okay, if GCD between A and B is equal to X, or, okay, yes, then it means answer plus by the frequency of B, right? Is it correct?
Don't you think we should multiply by frequency of A?
Yes, we also can do that. For example, A is from 1 to N, or from 1 to is maximum A. Yes, we can multiply with this. Okay, is it correct?
I think they will count it twice, a pair.
That's it. So, yes, so just divide by 2. Alright, alright. And of course, A and B will be different because X is non-zero. So, what is the complexity of this solution?
And log n, I think. Max of A log n. Because they won't be more than log. No, I think factors would be more.
Yes, you know, uh, root force for this is also like this. For X from 1 to maximum A, let's say maximum is N. And then for A from X to N, but like this. A equal to X, A less than or equal to N, A plus by X, right? So the complexity for X equal to 1 is ON, and then for X equal to 2 is N divided by 2, and divided by 3, and divided by 4, and so on. It's a harmonic series, right? Okay, because it is harmonic series, so alright, it is N log N. And we need another log, I think, for greatest common divisor. But it is quite fast. Okay. So this is the complexity. Alright. Okay. Any other questions for this? Okay, I think later you need to solve this. And also the juniors solve this as well. And the seniors, of course. Alright. Any other questions? Wait, this one is convex one. So do you ask about, alright. Did you ask me about convex hull? Okay, yes.
Sir, I know the theory of convex cell, but I think implementing it is quite hard. So, can you
Okay.
show us the implementation? Like, I think Abdullah also knows about the theory.
Alright.
It doesn't.
So
I don't know about the theorem.
alright.
But I have read the articles on it and on Wikipedia, but the like there are so many segmentaries. How to
No,
do all of them?
I think there is no segment 3.
Oh, that was convex hull, I think. Oh, convex hull. That was it. Yeah. Oh, heavy light
Do you
decompression.
mean this one? Okay, I feel like.
Heavy light decomposition.
Okay, yes. I feel like decomposition is. Okay, I feel like decomposition is segment 3 on 3, right? Alright. I think convection is in geometry, right?
We have done highlight decomposition with you, and you showed us two ways of it.
Okay.
One with an LCA and another one with
Yes. Either with LCA or. But LCA is.
or and another one, the common method. I forgot it, the name.
Okay. I think the if you like decomposition is the other one, not the LCA. There are two solutions for path queries, either using LCA or if you like decomposition. So the LCA one is not if you like decomposition. The if you like decomposition is the other one. Alright. Okay, but now we can discuss convex hull. Where is convex hull? This one. Wait. Okay, I have solved all convex hull problem in TLX. Maybe this one is the easiest. What is the problem? Okay. Do you know what is convex hull? Okay. Convex hull is, for example, given some. Okay. Given some points, and we want to create a polygon covering all the points with the minimum perimeter. Alright. Polygon with minimum perimeter. So because we want to minimize the perimeter,
Won't we have always a single choice?
yes, single choice.
So I think perimeter does not matter.
Yeah, yes. Actually, if perimeter is not minimized, we can make a polygon like this,
Oh,
right? Wait.
oh, yeah, got it.
For example, the polygon is like this.
Okay,
How do you think?
yeah, now I
The perimeter
understand.
is not minimized, right? In fact, we can shorten this become like this. We can shorten this become like this. Okay, so this is the minimum. How about the minimum area? Do you know how to minimize the area? If we minimize the area, actually, the area can be almost zero, near to zero. Or we can say it zero. Do you know how to do that? So, is this a
Can we visit
polygon?
twice?
Yes,
Uh, can we visit a place twice?
I think it is okay. Or maybe it is not visited twice, but it is near with this.
Okay,
The distance is nearly zero, 0.00001. Okay, so it is just like visited twice, right? Is this a polygon? How do you think? This is a polygon, right? Okay, there is a polygon. Wait, a polygon like this. And the area is zero, right? Okay. Or the other definition is like this. Uh, Okay, either polygon with minimum perimeter or convex polygon. I mean, sort covering all the points with minimum area, right? But this should be convex. So if we do this, it is prohibited because it is concave, right? If it should be convex, then yes, the minimum area is like this. Actually, we can make more than this. This is also a polygon covering all points, but the area is not minimum, right? Right, so it is convex. All right. So do you know how to find the polygon? Okay. There are two solutions. There are two algorithms. One of them is Graham scan and one of them is wait. Graham scan and also uh, what is the name of algorithm? Okay, let me check the sign of this. Okay, monotone chain. Graham scan and monotone chain. I think monotone chain is easier. Sorry. The solution is like this. We can take the leftmost points and then go to the next point and go to the next point because it is convex. Okay, then it is okay. But when we want to go to these points, then it is concave, right? It is concave. So we will pop this. We will erase this. Okay, now it is convex, right? Okay. And then if we want to go here, we need to pop this and then continue to this. And also for this, for example, this is concave, so we will pop this. If this is also concave, we pop this and make like this. This is also concave, right? Actually, before we go here, we will go here first, right? But then we pop this, and go here. And we want to go here like this. We want to add one by one based on the x position. So let's sort by x. Okay, after this, for example, go here. After this, go here, but this is concave, so we pop this. After this, we go here, for example, like this. Okay, this is convex, for example, and this one is concave, so we pop this. And then go to this point, concave, so we pop this, and so on. And this concave, for example, we pop. I think this also concave, and so on. This is concave, so we go here, for example, and then go to this, we pop, go here, and so on. Okay, I think there are so many dots here. And for example, like this, we want to add here, so we will pop this, and so on. And the final solution will be like this, right?
Sir, how are you checking the concave
Okay,
angle.
the code is like this. Okay, but before that, actually, we need to do it again, but starting from the maximum x. Starting from the maximum x, and just like reversing or rotating the coordinates, so we will get the lower one. Okay, and finally we got the convex hull. So this one called upper hull, and this one called lower hull. So in one iteration, we only get upper hull, right? And just do the same thing by rotating the coordinates. We got the lower hull, and finally we got the complete hull. All right. How to implement that? I think I have the implementation. Wait, but for this I'm using Graham scan, not the monotone chain. Maybe in the other problem. Okay, yes. Actually, just like sort the x. Wait, okay. And then add one by one. But how to add them? Before we push back the new node, while it is not convex, then pop back, right? Okay. So, for example, we have a vector of hell. We have a vector of hell. Before we push back a new point, we have to check with the back and before back, right? This one is before back, before last. And this is the last one. And this is the new point, right? We have to make sure they are convex. If they are concave, then we will pop back. All right. And how to check whether they are convex or not? We can check using dot product. Do you know dot product? For example, this is x and y. Okay, wait. For example, this is x1, this is y1. This is x2, this is y2, for example. And this is minus, I think. So if the dot product is positive, then it means it is convex. But if equal to 0, then they make a strike line, right? And if the dot product is less than less than 0, it means it is concave. Okay. Wait. Yes, the dot product is like this. If it is clockwise, then positive. Is if counterclockwise, then negative. If straight line, then 0. Right. Okay. And the formula is like this. Uh, for example, this is a first point a second, and this is b first point b second. This is c first point c second. So just find the distance between a second and b second, and a first with b first. Okay. Or we can also check the gradient. The gradient of this is the distance, the difference of second divided by this, right? You know, is if the gradient is greater than this, it means convex. But if the gradient is less than, then it is concave. If the gradient are same, then they form a straight line. So if we want to check whether they are convex, so we want to check like this. Okay, like this. The formula is like this. And just find the and just cross the product. So this one multiply with this, and then this one multiply with this. Okay. All right. So this is how to check whether they are convex or not. And we can do this to find the upper half, and then do the same thing to find the lower half. So that is the idea.
Sir, can you explain again why is it's not greater than equal to and only greater than when it's a straight line?
Okay. Do you know the gradient is like this? Gradient like this is minus. For example, gradient -2 is like this. Gradient minus half is like this. Gradient half is like this. Gradient 2 is like this. So it means here is the smallest one and here is the greatest one, right? So if it is clockwise, so the gradient is smaller, right? For example, like this, the gradient will be smaller. From this become this. Okay. But if concave, the gradient will be greater, right? If the gradient are same, then they make straight line. Okay. Okay. Is it your question?
Sir, I am asking that why did you write greater than in the function convex of a parent A, B, C?
Okay.
Not greater than equal to. Why is it
All right.
greater than? Because a straight
Let's
line
see.
is always neither convex nor concave.
Okay. For example, in this code,
No, on the upper function.
Okay, yes. Convex means greater, because if it is equal, then straight line. If less than, then concave.
Okay.
But in function at, if not convex, it means we pop it. It means
Okay.
if less
So we
than or
choose the
equal. Yes.
next. So we won't choose the straight line. We like it. Choose it or not choose it. It's
Yes.
same.
Both of them are same.
Yes.
Yes.
Got it. Thanks.
Alright. Yes. Welcome. Yes, I think if we make it equal, it is just same, but the number of point will be increased. For example, there is another dot here. If we take this or not take this, then the polygon are same. Alright. And this is the before last, and this is the last, this is the new. Alright. Okay. So that is the solution. Okay. And this is okay. This is the monotone chain solution. But there is another idea, that is Graham scan. So the idea are same, but we are not sort. We want wait. Okay, the point is not sorted by x, not sorted by x, but sorted by direction from leftmost point. So for example, this is the leftmost point, the pivot. This is the okay. Then we will sort based on the direction here. Okay. Okay. So this one is the first and this one is the last. Okay. And just do the same thing, but using this order. So let's start from this and this. Okay, this is convex and this is convex and this is concave. So we will want to pop it and so on until we got a shape like this, for example, like this. Wait, and so on. After that, like this, and then like
Sir, can you
this.
explain why did it go before, like the second point? Why did it go before and not after?
Okay, because
Because the direction is the least, like the one with the minimum y will be. I think
okay,
you said sorted by the direction.
okay. I mean sorted by gradient. So the gradient of this will be smaller than this.
Okay.
So the smaller one, so it is like this. This is the greatest gradient, and this is the smallest gradient. All right. So of course the gradient of this is smaller than this. This one is smaller than this. This one is smaller than this, and then this one is smaller than this, and so on. Okay, and finally we cut this. All right. Is it understood? So the idea is, at first we want to okay, we want to find the leftmost, I think. How to find the leftmost? Actually, it is easy. We just want to find the minimum. But in my implementation, I'm doing like this. If a point is less than this point, just swap them. So we can make sure x0 is the minimum, right? Minimum x means leftmost. All right. After making x0 is leftmost, then we will sort x1 until the last. Starting from 1, we will not sort x0, right? But I make a custom comparator. How to compare two points? We just check from the pivot. This x0, the leftmost one. Just check whether x0AP is convex or concave. Because if A is the gradient is less than, it will be convex, right? All element here will convex like this. Like this is convex, this is convex, this is convex. But if B is less than this, it will become concave, right? Alright. Checking convex using this formula again. Checking the gradient. Right? Alright, after sorting it, then just add them one by one from x0. Of course, x0 is added from the first time and then added by the next point. And don't forget, add x0 again to close the polygon, right? So the idea is like this. Start from the leftmost and then just do one by one from the smallest gradient until the greatest gradient. And then just add this line again, because actually if we are not adding this line, it become like this, right? Wait, okay, I think not. I think like this, because if this, then this will come first and then this. Okay, but if we want to make the polygon closed, then add this again, add x0 again, right? Okay, that's why my implementation is like this, adding from 0 until the last and then adding 0 again. Okay, and finally we got the convex hull. And in this problem, we need to find the area. Do you know how to find the area of a polygon? Not always convex. It is general for any polygon. Have you learned how to count the area? Have you learned about Sule's formula?
You told us before,
Okay.
but we never used it.
Okay. Okay, Sule's formula is how to find the area of polygon. The formula is easy. Just do this. Okay, let's say the point is on x1 point y1, x2 point y2, and so on. And just cross them. x1 times y2 positive and minus x2 times y1 and so on, like this. Do you know why? The idea is actually doing like this. From the first point, okay. From the first point to the second point, if we go to the right, it means it is negative. Okay, negative this. From 2 to 3, it is negative. from 3 plus 4, okay, it is goes to the left, so it means positive. So it means it will cancel each other. It become like this positive, this negative, right? And then we will remove this. It means now it is 0. And this one negative, negative. How do you think? Right? Now it is just like negative like this. And then finally added by positive like this. So now it is not counted. And we just count this in positive. Fine. Okay, is it correct? So we just need to find the area of trapezium like this. The area is the sum of y. Wait. For example, there is xi, yi, and xi plus 1, yi plus 1. Okay. The distance is, let's say, xi minus xi plus 1, right? If it go to the right, then it is negative. If it is go to the left, then it is positive. Then multiply by sum of two sides, two parallel sides. So size is like this. And then divide by 2, right? This is the area of trapezium. So we just want to find the sum of this. Okay. Yes. We just need to find the sum of this. And okay, I think let's write that formula. It is just like from 0, some from n to, okay, from 0 to n, for example, answer added by xi minus xi plus 1 multiply yi plus yi plus 1 divide by 2. I mean xn equal to x0, yn equal to y0, right? You know, it is equal to this, right? Just divide by 2 in the last. And then we can divide this into 4. Wait. Into this. Is it correct? Okay. And then let's divide this into 2 again. And then subtract with this. Is it correct? Okay. You know, for this, we will find the sum of all x times y, right? And for this one, it is also find the sum of x times y, xi times yi. So we can cancel this with this. Is it correct? So we just need to find the sum of this minus this. That's why it is just like Zule's formula. Alright. So this is the formula if it is counterclockwise. But if it is clockwise, then we have to make like this. So practically, we can easily make like this. Because sometimes it is negative if the direction is reversed, either clockwise or counterclockwise. Alright. So this is how to find the area. Okay. Any question until this point? Yes, the points will be in order. It is up to you, clockwise or counterclockwise. But actually, if the clockwise and counterclockwise is reversed, then it become negative. So please beware. You can try to input the sample. If your output is negative, then just change the sign. All right. Or you can simply make absolute value. All right. Any other questions? So that is the convex hull. But unfortunately, all of them are
So
in Indonesian language. Okay,
what
yes.
about the time complexity?
The time complexity is because we need to sort them. So it is n log n, right? But if they are already sorted by x, for example, we can use monotone chain. So it is only on, right? Actually, the algorithm is only on, but due to the sorting, we need n log n, right? Okay. Any other questions? Why on? Because the number of pop less than the number of push, right? And the number of push is on. And checking the direction is on. Okay. The English version is not provided. Okay. Yes, unfortunately, there is no.
I think we can use Google Translate.
Yes. We can also use
Or maybe VJudge
text.
also has an option
Yes,
to translate the problem statements.
that's it.
Or maybe somebody already had done it on VJudge.
Yes, for example, let's find TLX. You can try to translate it. All right, this is also convex error. Okay. Any other question about convex?
Still in Indonesian though.
Yes.
It's still in Indonesian.
Okay,
After
wait. Okay, yes. This one is the English version. Okay.
We have to calculate the upper hull.
Yes, we only need to find upper hull only.
Should we implement it or what?
No, I think just tell me the idea.
I think the same idea, but we have to do for the both sides of ball, like
Yes,
right corner and left corner at both corners.
yes, and it is already sorted. Wait,
Yes.
wait, is it sorted? Maybe not always sorted. Wait. Okay, then just sort them. Just sort them and let's make some points here, right? The position is x minus diameter divided by 2 point y and x plus diameter divided by 2 point y. Yes, and then just find the upper half. Okay, I think this is easy. You can solve it later. Any other question about the convex hull? Or any other question about the other topics?
Sir, I have a problem. Can we discuss that?
Yes, sure. Please share it. Share the link to me. Which problem?
Sir, it's not an issue, but it was an assignment for us. We have to do it by ourselves.
Sir didn't say we have to do it ourselves. He said take help from anywhere, even ChatGPT. So I think it isn't a problem.
Okay, this one.
So in this problem, the I think the problem can be reduced to the directed graph, directed cyclic graph, and we have to find the we have to add an edge and or remove an edge with queries and tell what is the longest uh, like path on this on the graph.
Okay, all right. Okay, wait. Please wait. Let's continue. Sorry. Okay. So do you have any idea? Right.
I think I don't have any idea.
So critic sequence is from a number we want to find the first number that is greater than this, right?
Yes, sir.
Okay. And then we want to find the maximum length of this segment,
Yes.
and then this segment, this segment.
Yes.
All right.
Yes.
Okay. Okay, I think, do you know how to find the first element that is greater than some elements?
Yes. We can use stack, I think.
We can use monotonic stack, right?
Yes.
Or we can find the previous element that is less than that.
Yes.
So for example, we have a monotonic stack, and if we want to push a new number, wait, sorry, I think it is sorted in increasing order.
Yes.
So if we have a new element, then we will pop this. Okay, the previous element will be here.
Yes.
All right. What else?
I think we should go from back.
Yes, I think it is symmetric. If we can go from back.
Because if we
Wait,
choose from either this third, so the answer would be the first one that is crossed.
yes. Wait. Or should we do this? For example, we have a monotonic stack. Then for each year, the answer will increase by one, right?
Yes.
This answer increase by one, increase by one, increase by one, and then pop this, pop this, pop this. Okay, so don't worry. But wait. But actually all value that can go to this increase by one as well.
Yes.
Okay. Okay, can we check the editorial? Maybe we also need to use DQ to solve the sliding window. Okay, I see. All right. So the solution is like this. After we know the next node
Yes.
and it become a forest, right?
Yes.
There are some tree. Or let's add another value with infinite value in the last. So it will be in the root, right?
Yes.
Okay. So basically, if we want to find a specific subarray,
Yes, sir.
let's just make this node is turned on. So this node is 1 and the other node is 0. All right.
Yes, sir.
And then we want to find the maximum path from the root to the leaf with the maximum sum, right?
Yes.
And how to do that?
Got it.
Actually, if we make it 1, so all its sub-tree will be increased by 1, right?
Yes.
Okay. So it means when we activate one node, just add the sub-tree by 1. If we turn off, turn some nodes off, then just subtract them with 1, right?
Yes.
And because this is 3,
Yes.
we can use Euler tool to make it a flat array, right? So when we increase a sub-tree by 1, just increase a specific range. If we subtract by 1, just subtract a specific range.
Got it.
And then
Query the
just
maximum.
find the maximum value for all this, right?
Yes, sir. Got it.
Okay, then that is the solution.
Thank you, sir.
All right. Yes. I think that's all for today. Thank you very much for the discussion. And
Sir, when are you gonna come Pakistan?
I don't know because I have some problem with the Paisa. I hope I can get the Paisa faster so I can to come to Pakistan earlier. All right.
May Allah ease your problems.
Okay. Thank you very much. Okay. That's all for today. Let's close our meeting with praying. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Amin. Assalamualaikum warahmatullahi wabarakatuh. Allah
Walaikum salam, sir.